Gingside.com. Gingside.com.
Howdy, howdy, howdy. Welcome to the lesson on file input and output, otherwise known as I/O. RAM memory is transient. It disappears without power. If you turn off your program, shut down your computer, anything stored in RAM memory disappears. Disk memory is persistent. It sticks around after shutdown. If you lose power, if your computer reboots, disk memory is persistent. It'll be there. Most programming languages allow for read and write of files. Data written to files can be read days, weeks, years later. It's persistent. It sticks around. The only thing that prevents it from sticking around is something like a hard disk crash, and hopefully you won't go through too many of those. Since most computer languages access files in a similar manner, I will try to make this as generic as possible. What you're going to need to do is create a program to write a file and then run that program. A consistent step across computer languages is the need to open a file. File I/O has to be done through the operating system, or OS. The programmer requests access to the file or disk using some sort of open command. It's not always literally open, and it varies by language what the command is to open the file. But more importantly, it tells the operating system that that file should go on special status. We're about to use it. Write to the file the information my data. The program issues a command to write or output data to a file. Again, this varies by language. Passing through the operating system, the data is written to the disk. So as you can see here, the information my data passes through the operating system and makes it out onto the surface of the hard drive. Once it's there, it should be persistent. Now you need to close the file. It's extremely important to let the operating system know you are done with the file when writing. The operating system blocks access to the file, and the close restores access to the file and flushes any remaining data to disk. I never consider a write complete until I'm sure the file has been closed and the data has been flushed to the hard drive. Now let's flip it the other way. We've written this information to the hard disk. How do we get it back? Well, we need a program that will read the file. Let's create this public class read program to read a file and run it. Does not have to be a separate program. A same program can read and write files. Note the open, read, and write close pattern that we are going to view here. The programmer requests access to the file or disk using some sort of open command. That open command varies by language. Some languages specify access mode on open. You sometimes have to declare, I'm opening this file for reading, or I'm opening this file for writing. It varies by computer language. But all languages have some sort of open command to inform the operating system we are about to access a particular file on the disk drive. Reading the file. This is sort of a two-way command. We send the request to read the file, and the information from the file comes back. Notice how the arrows go in both directions. So the request is made to read the file. If the data can be read, it's read and sent back through the operating system to the computer program. The program issues a command to read or input data from the file. Again, it varies by language. Passing through the operating system, the data is sent from the disk to the program. Closing the file. Extremely important to let the operating system know you are done with the file. When reading files, the operating system must know which programs are currently accessing the file. This close tells the operating system that the file is no longer in use by someone else, so if someone else wants to write to it, they may. That was a very, very generic description of file I/O. My main point is you learn the pattern with most programming languages. Most programming languages open the file first, you then read or write the file, and then you close the file. The exact sequence and commands you use varies from language to language, but everybody has to open, read, write, and close a file. Mostly so we can inform the operating system which files are in use. Writing or outputting a text file. We're going to import the Java IO package here in the first line of code. A package is a group of classes. The star wildcard matches many classes. This code adds the following classes to the program: the file class, the printwriter class, the exception class. In Java, we must import classes that our program needs in order to use them in the program. This is a typical first line of a program. I decided to call it write program because we're going to output some data to the disk. You can call it anything you'd like. Do give it a descriptive name. Describe what the program does in the name of the class. Here's a typical public static void main function, but there's something new on this line, and at the end there's that throws exceptions. Many things can go wrong when accessing a file. The file's not found. There's no such directory. There's no write permission to the file we're trying to access. Adding the throws command to the method header is the easy way to process errors in file I/O. It is not the best way. It prints an error message and terminates your program, but it is the easy way to handle problems when opening a file. We'll look at the try-catch command in a little bit. It's better, but let's start with the easy way and we'll look at try-catch later. Always put that throws exception at the end of any method that does file I/O, and that's the easy way to handle errors. We're going to create a string file name equals data.txt. Using a variable to specify the file to open is much better than hard coding. In this case, the file will default to working directory, which is your project folder in many IDEs. The .txt is not required, but informs anyone looking at the file it is a plain text file. Int age equals 19. This is a simple variable to demonstrate how data from a non-text item is output to a file. Code below shows hard-coded data and data from a variable written to a file. Note using variables is almost always a better way to output data to a file. So I wanted to set up this variable just to show you that you can write variables to the files and their contents will be written. File, file object equals new file, file name. What we're going to do here is set up a file object. It's important to create a file object to access a file on a disk drive. A file object is a 100% requirement for accessing a file. As an OOP language, objects are needed to do most, if not all, file operations. Get used to it. Is this the file open I was talking about? At the very least, this is step one of opening a file. A file object is needed to access a file, and it will not open without a file object. Here's the file object as it's created in computer memory. File object is a reference to the object that is going to be opened on data.txt. Printwriter output equals new printwriter and pass it the file object we just created. A file is certainly open for write access now. A printwriter object is one of several ways to write or output data to a file. Note the file object parameter. You can bet this object will be using the reference to the file object. This call is destructive. If data.txt contains existing information, it will be written over. We are writing new contents to the file data.txt, and any current context to the file might be lost. Trying to illustrate what happens in computer memory here. Printwriter is an object in itself. It's open on this data.txt file. That's what this reference is showing you here. And that data.txt file is going to be written to the hard drive. System.out_print John Doe is, I'm just going to output some text to the screen. By now, students have used system.out many times to display to the console. Everything you've ever learned about system.out can now be used to do file output. This example is here to demonstrate how identical console output is to file output. It's not required to do file output, but you'll see file output is very similar, and I want to show you the similarities. Output.print John Doe is. Notice how this line of code is lined up. I've lined it up this way so you can see that these two commands are very, very similar. But this time, instead of writing to the console, we're going to instruct the system to write to the file. The output object, which is this print writer object here, is instructed to output John Doe is to the file, and you can see the information is flowing towards the file. Use system.out when you want the output to go to the screen. Use this output object when you want it to go to the file. Let's write data to the file. Go to the output object and run the print method. That's this left arrow shown here. Then have the print method send the data to the file. That's the right arrow shown here. Notice how it's spaced. Pretty much everything you've ever done with system.out will work with this output object. This is inheritance. Both objects inherit the methods from the parent, so both objects, system.out and output, behave the same. System.out println age, we're going to output the contents of the age variable to the console. So write the contents of a variable to the console. Note the .print does not end the current line, but .println does. There will be a \n after the 19 outputs here. Using variables is much better than using hard-coded values. Everything you are used to doing with system.out, including printing variables, will work exactly the same with files. Output.println age. This time we're going to output not to the console, but along these arrows to the file. Let's write the variable contents to the file. Go to the output object and run the println method. That's this left arrow here. We ask the output object to run println. Send to the file, this right arrow, send the output to the file. Notice how it's spaced. Pretty much everything you've ever done with system.out will work with output. Now the \n's are important because if you're going to open and read this file using notepads, you're going to need end-of-line characters. Also, this is again an example of inheritance. Both objects inherit methods from the parent. So both objects have a method that will output the integer variable to the console or to the file. Output.close. This is extremely important. You must close the connection to the file data.txt. It's important for two reasons. Number one, it releases the lock on the file that prevents others from accessing or changing the file. And number two, it flushes any pending writes to disk. Never consider a write to disk complete until the close is done. Small data writes are buffered until the flush is done. The operating system isn't going to go back and forth writing a little tiny bit to the file each time. It waits till it accumulates a bunch of data, then flushes the whole thing out. This close command makes sure that your data is flushed to the hard drive. Also, I put a little line through the methods because once you close the output object, do not expect to use the methods of the output object. The file is closed. But far more important is understanding this idea of a flush. When you close a file, any remaining data that isn't yet on the hard drive will be written to it. Here's my closed curly brace to end my program. The closed curly brace will end the program and delete all my local variables. And now my file I/O, my write to the disk, is complete. Before we leave this slide, let's look at some options. This here in the red box is called an absolute file name. And it kind of sucks. Very Windows specific. It won't work on other systems or another machine without the C:\Java folder. But sometimes students tell me they don't know where the project folder is. That's sad. But this leaves no doubt where the file will be. It will be on the C drive in the Java folder. Again, I want to discourage you from doing this, but if you're experimenting and see how this works, you can try an absolute file name and see that the file shows up exactly where you told it to put it. Before we leave this slide, let's look at some options. This is called a relative file name. In the red box, I'm setting up file name to contain a relative file name or file path. It says the file will be in a subfolder Documents of the current working directory. Now this works on any system. Is very useful if you're creating hundreds of files. Just be sure there is a Documents folder in your current working directory, or it's on File Not Found error. Again, for an IDE, the current working directory is usually your project folder, but that could vary from system to system. It's critically important that you understand this idea of a working directory. If you're using something like NetBeans, it's your project folder. Otherwise, it might be the folder where your program is executing from. You can hard code a file name, but it is not a good idea. Here in the red box, I'm opening or accessing a file object, and I've hard coded a file name while I'm creating the file object. What if your program has 15 different places where it opens a file? That is 15 different lines of code that you would have to edit. Better to use a variable like I did above. If you use a variable and you change this one file name, it changes everywhere you open a file, not just one line of code. I know I lecture a lot about not using hard-coded values, then use them in my examples all the time. What you need to understand is I have to keep these examples small enough to fit on one slide. So I use some hard-coded values like John Doe is and the 19 here because it keeps the example short enough to fit on a slide. In the real world, please try to use variables as much as you can. Do not hard code data throughout your programs. Here's a way to code it so you don't have to change the code even when the file name changes. Here in the red box, I tweak the code to get the file name from the arguments parameter. Notice the string array args being sent to the main method. Well, this is for input to the program, and you can pass it information when you run the program. The args parameter domain is for the command line arguments you pass when the program's run. So if you manually run this program, Java write program data.text, this would be args0. Now the user of the program names the file, and it can change all it wants, and the program doesn't have to be changed or recompiled or rerun. You let the user pass the file name that you want to open. There you have it. That's writing output to a text file. I wrote one specific program to write output. As I said before, you can write programs that read and write, but once again, I have to keep these small enough to fit on slides. So I put one write-only program on this slide, and the next slide will be a read program. Let's look at reading input from a text file. Just a small example program that will read or input a previously created text file from the disk. This program is going to assume that a file already exists on the hard drive. Need to do our imports? We'll import java.io.star. We'll import java.util.scanner. Import the Java IO package. A package is a group of classes. The star wildcard matches many different classes. This code adds the following classes to the program. File, which we need to access, the file, the exception class, and the new import adds the scanner class. By the way, this is the exact same scanner class used many times before to get input from the keyboard. We are now going to use it to get input from a file. Typical first line of the program, I call this public class read program because all this little program does is read from the file. Public static void main, typical first line of main. We add the throws exception. That throws exceptions is new. Many things can go wrong when accessing a file. File not found, no such directory, no read permission on the file. Adding the throws to the method header is the easy way to process errors in file I/O. It is not the best way, but it is the easiest way. It prints an error message and terminates your program. Very easy. The try catch command is better. We'll cover it in a later slide. For now, every method that does file I/O, if you add this throws exception to it, it will handle any errors for you by printing error messages and terminating your program. String file name equals data.text. Then I'll declare some other variables. First, last, is. Using a variable to specify the file to open is much better than hard coding. In this case, the file will default to the working directory, which is your project folder in many IDEs. The .text is not a requirement, but informs anyone looking at the file it is a plain text file. The first, last, and is are variables to hold data read from the file. Int age is a simple variable to demonstrate how a non-text item read from the file can be processed. To be clear, all data in a text file is letters, but the scanner class will be able to read the text data and convert it to a numeric type, just like it does with keyboard input. I wanted to show that functionality. File object equals new file name. Here's the file object being created in computer memory. This file object will be attached to the data.text file. It's very important to create a file object to access a file on a disk drive. A file object is a 100% requirement for accessing a file. As an OOP language, objects are needed to do most, if not all, file operations. Get used to it. Is this the file open? At the very least, it's step one of opening a file. A file object is needed to access a file, and it will not open without a file object. In a later slide, we're going to learn an update to the file object. It's called a path. We'll building path objects in a later slide. It's very similar to building file objects. Scanner input equals new scanner, and notice the parameter. The parameter is the file object created on the previous line. The file is certainly open for read access now. A scanner object is one of several ways to read or input data from a file. Note the file object parameter. You can bet this object will be using the reference to the file object. The beauty of OOP is everything you ever learned about keyboard input using scanner now works, but now the input comes from a file. The only difference between this scanner object and a keyboard scanner object is the data will come from a file. First equals input.next. By now, students have used scanner objects many times to input data from the keyboard. Everything you ever learned about scanner can now be used to do file input. The lower arrow is the input object's next method. The input object is calling the next method, asking for the next word of input from the file. This John right here. The upper arrow is John being returned to the first variable. Input object makes a request to read one word of data. That one word of data gets sent back as the return value from the next method, and it's assigned to the first variable. Let's do it again. Last equals input.next. The next method uses white space characters as a delimiter. The second call to next picks up the dough between the spaces in front and back of it. Although the spaces are critical in determining what is returned, the spaces themselves are stripped out when using the next method. Input.next is called, and it grabs the data between these spaces here. And the spaces are skipped. Just the letters DOE, dough, are grabbed by the call to next, and they are sent back to the caller, and DOE is assigned to the last variable. Space delimited. All of these spaces between John and dough and is and 19 are what we call delimiters. They separate data in the text file. Is equals input.next. I'm literally going to read the word is from the file. The third next method call returns is, the third word or token from the file. It is the third string of non-space characters with a space in front and back of it. Although the spaces are critical in determining what is returned, the spaces themselves are stripped out when using the next method. The input object tracks where it is in the file. So again, this is the third call. So the third token or the third word is read and sent back to the next method and assigned to the is variable. Once again, the spaces are critical. They separate the tokens or words in the file so the next command can pick up the next one. Also, I want to explain here, after the word is read, the file pointer is pointing to the data after the word is. The scanner object tracks where in the file is currently being read. So at the beginning, it started on the J. And then after the next call, it was on the D. After the next call, it was on the I. And now the file access pointer or reference is pointing to that 19. Age equals input dot next int. I'm using a different command. Instead of next, which returns text, I'm calling next int, which returns an int. The next int method calls and returns 19, the fourth word or token from the file. It is important that token be a numeric characters, or there will be an error. This happens on the keyboard too. Whenever you call next int for the keyboard and type in letters, you get a big fat error message. And the same would happen here if the file didn't contain a number at that point. It also uses the backslash end of line character as a white space at the end, but strangely leaves it in place. It is reading the letters 19 from the text file. Then next int converts and returns an integer. So next int is called, and it grabs the 19. Now, this is a text file. This is the letters 19. So next int reads the letters 19, converts it to the number 19, and sends it back to the user, and it's stored in the age variable. This is an example of reading the file word by word or token by token. This is just one way to read the file. It is not the only way to read a file. Just to confirm we read data from the file, I'll do a system.out. I'll print the first name, I'll print the last name, I'll print the contents of the is variable. Notice how I didn't put any spaces between it. And then I'll put a space and output the contents of the age. This is to show you that the next method clearly strips the spaces. And this print line proves it. The letters are smushed together. I added a space before the age variable just to show you how it would be done. The next example will show you how to preserve the spaces. But keep in mind, the next method strips out the spaces. Everything you ever did with the scanner to get keyboard input works the same. Just pass it a file object, not system out. So the moral of this program is we already know how to do file input because we already know how to do keyboard input. And it's done exactly the same except when creating the scanner, we pass it a file object. Notice how all the spaces are crunched out of this. John Doe has no spaces. The next command does not preserve the spaces in the text file. Let's input.close. I cannot stress how important closing the file is when you're done with it. The close connection to the file data.txt. Programs are only allowed to have a limited number of files open at a time. The operating system tracks who is using a file. The OS will give an error message to another program that tries to write to this file while it's open. So it's important to close it to free access to that file. I never consider file complete until the close is done. Also, this is showing you once you've closed that file, you better not try to call those next or next int methods. You no longer have access to the file after it is closed. The closed curly braces mark the end of the main. Here's the closed curly brace. I bunched them up on the same line. Please don't do this. Please put these on separate lines. But I was running out of room, so I had to put them on the same line. The closed curly braces mark the end of the main and the class itself. The variables created in RAM, as they should, disappear. The first, last, and is variables, they all disappear. Stopping the program, let alone powering off the computer, is enough to delete any data stored in RAM. But what sticks around? The data written to disk does. A day, a week, or a year later, it is still there, ready to be loaded back into RAM. If a month later I run this same program, a month later I can pick up this data. Data stored in RAM is transient. All of this goes away when the program's done. Data written to the hard drive is persistent. This data sticks around. Before we leave this slide, let's look at some options. I changed the name to the file that does not exist. Blah.txt doesn't exist. What I'm going to do is try to open a file that is not on the hard drive. This will cause the scanner open of the file to fail. This will cause the throws exception to print a file not found error message and crash or terminate your program. A try catch statement may be a better solution, but we'll look at that in a later slide. Let's look at what happens when we try to open a file that doesn't exist. It will blow up the program. It takes a very slight tweak to system.in to convert this program scanner to get input from the keyboard instead of the disk file. What I'm showing you here in a red box is just a reminder of what we used to do with the scanner. You used to use system.in to get input from the keyboard. If I changed this program to use system.in, notice how similar keyboard input and the text file input it. Even things like next strips out the spaces and next int fails if it reads non-numeric data, exactly like the same file or keyboard input. You could run this program now, and now it would be getting input from the keyboard instead of the file. I'm just tweaking with little things here. Here is a way to code so you don't have to change the code even when the file name changes. I'm going to set string file name equal to args square bracket 0 end of square bracket. I'm going to use the input parameters of the program to get the file name. The args parameter main is for the command line arguments that you can pass when the program is run. If you manually ran this program, Java read program data.txt, data.txt would come in as the argument 0 in the args array. Now the user of the program names the file, and it can change all it wants, and the program itself does not have to be recompiled or changed in any way. Keep in mind, the file written to the disk is still there. On the next slide, we'll learn how to read the data without stripping the spaces and learn to use the try-catch commands to handle problems. Text files are nice because they're easy to change. A program like Notepad or an IDE editor can open and edit a text file. Let's assume for the next example, the file has not changed. A second small example program that will read or input a previously created text file from the disk. This time, the spaces in the text will not be removed, and try-catch will be used to handle any errors. Let's do the import of java.io.star, end of scanner. Import the Java IO package. A package is a group of classes. The star wildcard matches many. In this case, we're going to need access to the file class and the exception class. The code adds the following classes to the program: file, exception, and scanner. This is the same scanner class used many times before to get input from the keyboard. Typical first line of the program, I called it read program 2 this time because it's a second example of a program to read from a disk file. This line has changed. We're back to our normal public static void main string array args line. There's no throws at the end of this line. The header's throws exception has been removed. Many things can go wrong when accessing a file. File not found, no directory, etc. Adding the throws to the method header is the easy way to process errors in file I/O, but it terminates your program. The try-catch can handle the problem without the program catching. So in many ways, try catch is superior than doing the throws command at the end of the method. String file name equals data.text, and then we'll declare a second variable line. Using a variable to specify the file to open is much better than hard coding. In this case, the file will default to the working directory, which is your project folder in many IDEs. The .txt is not required, but informs anyone looking at the file name it is a plain text file. Variable line will hold the text read from the file, including the letters 19. This time we're going to read an entire line of data from the file rather than reading it word by word. File object equals new file, passing it the file name data.text. Very important, create a file object to access the file on the disk drive. A file object is a 100% requirement for accessing a file, although in newer versions of Java they have a version of this called path. And instead of creating a file object, you create a path object. It's very similar, but new versions of Java use the path object instead of the file object. As an OOP language, objects are needed to do most, if not all, file operations. Get used to it. Now, is this the file open I keep talking about? At the very least, it is step one of opening a file. A file object is needed to access a file, and it will not open without a file object. The try command, here's the try command right there. The try command literally says try this code, see if it works. If it does, great, execute it all and skip the catch. But if it fails, the catch is there to catch the exception and process it without necessarily program termination. The programmer/code then decides what to do. Do you want to print the error message? Do you want to ask the user for a new file name? And if it does want to, it could terminate the program. The use of the try catch allows the programmer to decide what to do when an error recurs. Inside the try, we're going to set up a scanner input equals new scanner and pass it the file object. This is the same thing we did in the last example. The file is certainly open for read access now. A scanner object is one of several ways to read or input data to a file. Note the file object parameter. You can bet this object will be using a reference to the file object. The beauty of object-oriented programming is everything you ever learned about keyboard input using scanner now works. But now the input comes from a file. All we're doing is opening a scanner on our file data.text. So the input will come from data.text. Line equals input.next line. Give me the next line of data from the file. By now, students have used scanner object many times to input from the keyboard. Everything you have learned about scanner can now be used to do file input. The lower arrow is the input object's next line method asking for the entire line of input from the file. This lower arrow here says the scanner object will request the next line of data from the file. The upper arrow is being returned to the line variable. So once it's read the line of data, the upper arrow shows you it being returned and assigned to the line variable. System.out.println line. Print the text that was read from the file into RAM memory onto the console. Note, this time the 19 is text characters. Since this is stored in a string variable, we will output the text characters 19 to the console. More code may be needed to extract and convert it to an int to restore it to a number. The read of the entire file would use a loop. This tiny little bit of code here would read the entire file. While input has next line, line equals input.next line. As this spins, it will read multiple lines from the file. There's several commands that you need to be aware of that will work with a scanner object. The has next command return true if there is data available in the text file for reading. The has next command will tell you true or false if there's an integer available next for reading. Next line tells you there's another line available for reading. Calling these has commands are very important. You don't want to go read an integer unless you're sure there's an integer in the file. You don't want to read a line unless you're sure there's another line in the file. When this file runs out of data, the has next line will return a false. When the has next returns a false, the loop will exit and it will stop reading the file. As always, input.close is extremely important. You need to close the connection to the file data.txt. Programs are only allowed to have a limited number of files open at a time. The operating system tracks who is using a file, and the OS will give an error to another program that tries to write to this file while it's open. Never consider file I/O complete until the close is done. I put a little red line through the methods here because once the file is closed, you shouldn't try to access it using this scanner object. The closed curly braces here at the bottom, once again I bunched them up. I don't like doing this, but I ran out of room, so I had to put 3 on one line. Do not do that in your program. Space them out. Put each closed curly brace on its own line, hopefully lined up underneath the open curly brace it marks. These closed curly braces mark the end of main and the class and the catch. When the try completes without an error, it will skip the catch. You do not execute any code in the catch if there is not an exception or an error. Local variables will be deleted. Beware of variables declared in the try block. See how input is declared in the try block? That means I can only use it inside the try block. If code was added to this program after the try catch, the variable input would not exist. It is local to the try statement. To use it outside the try block, you'd have to declare input above the try, just like I declared file name and line and file object above the try. Let's run the program again with a file name that will create a file not found error message and see how the try catch handles the problem. Notice in the red box, I gave it a bad file name. You don't see a blah.txt file on the hard drive. It is a perfectly bad file name that does not exist. With the old throws exception, the program would terminate. But now catch will run instead. At this point in the code, in catch, we can decide what to do. We could terminate the program. We could change the file name. We could ask the user for a new file name. Not that that was shown in this example. I don't have room. But the catch can decide what to do when a file exception occurs. I'm actually going to trace this example all the way through so you can see what happens when an exception occurs. File object equals new file and pass it the file name. Note, technically this is not an error. A file object can be created for a file that does not exist. If the code was planning on creating a new file, PrintWriter needs a file object to create it, and you quite often create a file object without an existing file on the disk. But in this example, we're trying to read a file, not create one. And you cannot read a file that does not exist. The arrow shows the file object name does not match the name of the file on disk. We have this file object open on blah.txt. It's not on there, but the error will not occur at this point. It will occur later. Here's our try command. It literally means try this code, see if it works. If it does, great, execute it all and skip the catch. But this time, the code will fail and the catch will be needed. Let's see how this happens and how the code in the catch deals with the exception. Bang! In the red box is the line of code that actually produces the error. Trying to create a scanner object on a file blah.txt, remember this file does not exist, that will fail. Since the code is in the try block, it will jump straight to the catch and execute the code. See this arrow from that box down to the catch? It's going to jump from this line of code, which failed, to the catch and execute the catch. Everything after it, this code here, will be skipped. When the try fails, it goes straight to the catch. Do not pass go, do not collect $200. Jump from this line that failed to the catch and execute the catch. With throws exception, this would have been the last line of code your program executes. Nothing after this line would have executed if we had a throws exception up here. But with try catch, the code in the catch will execute, and our program in the catch can decide what to do. When the new scanner fails, it jumps to the catch. That looks like a parameter E to catch because it is one. It is a reference to an exception object that contains a message explaining the problem. See this E variable with the arrow above it? That is a parameter to the catch that will tell us what happened. The code inside the curly braces of the catch can now execute and deal with the problem using the information provided by the E parameter. System.out println error plus E. I'm outputting to the console what happened. It's going to be some sort of message like error : blah.txt file not found. Notice how the blah.txt file not found is coming from the reference E. I was running out of room. I only had space for a simple message, but I do want to emphasize the code in the catch can be so much more. It could have issued a message, then asked the user for a new file name. It could have looped back to try and open the file again. The point is, the try catch lets you decide what to do. The throws exception crashes right away. Okay. So my code just exits after the catch anyway, but it doesn't have to. See the 3 curly braces lined up there? Again, try not to code this way. I'm out of room. You can see I'm at the end. I'm out of room. I normally would put these 3 curly braces on 3 separate lines. So what happens after the error message is my code just exits anyway. It doesn't have to. Here is a student experiment. Start with this code. Write a loop and ask the user to input the name of the file to open. Write another loop inside of the try to print all the lines of the file. When it fails to open the file, upgrade the code in catch to make it re-ask for the name of the file without crashing the program. I could add a loop to this program that says input the name of the file, and it just keeps outputting files without terminating the program if one of the files doesn't exist. See if you can improve this code. Adding a simple throws exception to the method header is the easy way for beginner programs to do file I/O. Go ahead and try it. Let the program crash if the file is not found. But advanced programmers, real software coders, need to use try catch. It is unacceptable to have the code crash. It needs to handle minor exceptions and crash only when a serious major error occurs. Experiment with the catch command and see if you can get your program to recover from errors rather than terminate. Path versus file. As of Java version 7, there is a new sheriff in town. A path is now used to access a file rather than a file object. New features that replace old features are always tricky. Most of the existing code out there and many of the examples on the web still use file objects. But new code being written today should probably use a path to access a file. So I'll do a little example using a path. The only real difference here is we're using a path object when we open a file as opposed to a file object. But other than that, it works pretty much the same. Consider the path to be an improvement or an update to the file object, so use it when you can. The NIO package contains the path interface and the path class. Since a direct object cannot be created from an interface, use the paths class to create a path object. This will be the replacement for the file object. The import of IO star and the scanner still are needed. I just didn't have room up here to show all the imports I needed. These are the new imports, and I really want to emphasize them because this is what you have to import to use the path. The change to the program is pretty simple. Instead of creating a file object, see the line below, create a path object. Just about everything a file object does, a path object does better. No need to rewrite the existing code, but new code should use path. Note, path with an S is a class. Calling the static method get will return an object of the interface type path. You cannot use the new command on an interface. So this is the new line of code that replaces the old line of code that used to create a file object. There's the old way we used to do it. File object equals new file name. I left the old way to gain access to the file in a comment. Millions of existing lines of Java code use file objects to access the file. You still need to know how to use it. Note, file is a class, so a direct object instance can be created. Path is an interface. No direct objects can be created. You have to use that get method to get a path object. Not really a different line of code, but if you look at the scanner version 7 or above documentation, there is a constructor that takes a path object. The old constructor that takes a file object is still there and still works. For new code, use a path. It is an improvement. Start moving away from file objects and start using path objects. Notice how I called this variable path object to illustrate the difference. Important. Very easy to go back and forth between a path object and a file object. If you have an existing path object and need a file object, simply call the toFile method. Look at this line of code. File object equals path object.toFile. It's going to create a file object that I can use to access this very same file, data.txt. This line of code does not do much, but sometimes there is a method that only takes a file object as a parameter, and a quick call to toFile will allow you to use that method. Path object 2 equals file object toPath. Important, very easy to go back and forth between a file object and a path object. If you have an existing file object and need a path object, simply call the toPath method. This line of code does not do much, but sometimes there is a method that only takes a path object as a parameter, and a call to toPath will allow you to use that method. These two lines of code basically just show you how to go back and forth between a file object and a path object. As of Java version 7, some code will use file, some code will use path, and whenever you need one or the other, it's easy to go back and forth. Usually when Java upgrades a class, the documentation is plastered with warnings not to use the old class. In this case, not so much. It leads me to believe the file class is not going anywhere anytime soon. But it is important to know both ways to access a file, using a path and a file object. There you have it. There's my intro to reading and writing text files. Remember, path is a new feature. You may keep encountering the file object in the previous code that's written, so know both ways to access the text file.
Gingsci.com